Okay, in this example, we want to find the cosine of 1020 degrees. Now, we could draw an angle that's 1020 degrees, but that would be a lot of revolutions. So here's a little shortcut to this. For any angle that's not between 0 and 360, add or subtract 360 until you get a coterminal angle between 0 and 360. So let's take 1020 degrees, and we're going to keep subtracting 360 until we get an angle that's between 0 and 360. And we learned in the last section that these two angles are going to be coterminal. So 1020 minus 360, um, that, and I should have worked this out. So I have 1020 minus 360. This gives me 660. If I take 660 and subtract 360, that gives me 300 degrees. And this is between 0 and 360, so now I can work with this angle. So 300 degrees, I start here. I have 90, I have 180, I have 270, and then I have 30 more. That gets me to 300 degrees. Okay, so once again, I have 90, 90, 90. That's 270 plus 30 is 300. So my reference angle is always going to be made with my terminal side and the x-axis. So my reference angle theta prime is going to be 60 degrees. Now let's put in the ratios. If this is 60, this is 30. Opposite of 30 is always 1. Opposite of 60 is always radical 3, but because it's in the negative direction, it's negative radical 3. And then opposite of 90 is always going to be 2. And the hypotenuse is always positive. But because here we're going in the negative direction, it'll be negative radical 3. Now what are we looking for? We're looking for the cosine of 1020 degrees. The cosine of 1020 degrees will be the same as the cosine of theta prime. So for theta prime, our adjacent is 1 and our hypotenuse is 2. So there's our answer. And of course, you can check this using a calculator. Let's take the next one. You have negative 675 degrees. We always want to get an angle between 0 and 360. So if I add 360 to it, okay, so if I take negative 675 and I add 360, this gives me negative 315. Now I'm still not between 0 and 360. So what am I going to do? I'm going to add 360 more. And if I do that, this gives me 45 degrees, a nice and simple angle. Now my reference triangle is going to be created, or reference angle is going to be created with the terminal side and the x-axis. So my reference angle is actually just 45 degrees, nice and easy. So opposite of 45 is 1, 1, and radical 2. We're looking for the sine. So the sine of negative 675 degrees will be the same as sinus theta prime. This is my theta prime. So that's going to be opposite over hypotenuse, which is 1 over radical 2. And if I rationalize that, that'll give me radical 2 over 2. Lastly, I have negative 510 degrees. So once again, I add 360 to it. So this gives me negative 150. That's now between 0 and 360, so I have to add 360 again. And if I do that, this will give me 210 degrees. So 210, let me sketch that. I have 90 plus 90 is 180, and 180 plus 30 is going to be 210. So my reference angle is always going to be created with the terminal side and the x-axis. So my reference angle is going to be 30 degrees. That's my theta prime. Now let's put in the ratios. Opposite of 30 is 1, but because we're going in the negative direction, it's negative 1. Opposite of 60 is going to be radical 3, but because we're going in the negative direction, it's negative radical 3. And opposite of 90 is going to be 2. Okay, so now we need to go through and we need to find the tangent of this. So if I want to find a tangent of negative 510 degrees, that's the same thing as tangent of this theta prime. Tangent is opposite over adjacent. So this is going to be negative 1 divided by negative radical 3. Now, first off, a negative over negative is positive. And if I rationalize this by multiplying both numerator and denominator by radical 3, this is going to give me radical 3 over 3 as my final answer. Now let's talk about the trig functions of quadrantal angles. What is a quadrantal angle? A quadrantal angle is any angle that's on either the x or the y axis, the positive or the negative. So those angles are 0 and 360, 90, 180, 270, and then back to 360, which is why 0 and 360, they're coterminal. All right, so let's find a point xy on the terminal side of these angles. Now we want this to have a radius of 1. So this is called the unit circle. A unit circle is when you have a circle with a radius of 1. So this point here is a point 1, 0. This is for 0 and 360. For 90 degrees, this point is 0, 1. For 180, this point is negative 1, 0 because you're going in the negative direction. So this is for 180. And then finally for 270, this point is 0, negative 1. X is 0, you're going down 1, and then for 360, it's 1 and 0 again. Now remember that cosine is adjacent over hypotenuse. So let's take a look at a triangle here. This is a triangle, and this is theta. Cosine is adjacent over hypotenuse. Now remember, adjacent is going to be the x value. So since the adjacent side is the x value, cosine is associated with the x value. So remember to associate cosine and the x value. Sine is going to be opposite over hypotenuse. So remember, sine is opposite. Opposite is the y value. So sine is going to be associated with the y value. Now tangent is opposite over adjacent. So tangent is going to be opposite over adjacent, which is y over x. So tangent is going to be y over x. Cosine is x, sine is y, tangent is y over x. And then because the radius is 1 in a unit circle, the radius is 1, cosine of a quadrantal angle is just x, and that happens because we have a radius of 1. The sine of a quadrantal angle is just y, and then tangent is going to be y over x. And the cosecant is going to be the reciprocal, which is 1 over y. Secant is a reciprocal of x, which is 1 over x. And then cotangent is a reciprocal of y over x, which is going to be x over y. So now let's use these to find the sine, cosine, tangent of the following. So for 0 degrees, first thing I'm going to do is I'm going to write the corresponding point, which is a point 1, 0. 1, 0 has a value of x value of 1, and a y value of 0. So if I want the sine of 0 degrees, remember sine is associated with the y value. Okay, sine is the y value. The y value of 0 degrees is 0, so sine of 0 will be 0. Cosine of 0, cosine is associated with the x value. Cosine is the adjacent, so it's the x value. Cosine is the x value of a quadrantal point. So cosine of 0 degrees is going to be the x value of that, which is 1. And then tangent of 0 degrees is going to be y over x. So the y value is 0, the x value is 1. Tangent of 0 is going to be 0. Let's take 180. So for 180, first thing I want you to do for any quadrantal angle is write down the point, which is negative 1, 0. Write down its x and y value. Okay, so we know that sine is associated with the y value. The y value is 0. Cosine is associated with the x value, which is negative 1. And then tangent is going to be y over x. So tangent is going to be, you know what? I'm so sorry. Over here, okay, no, we're good. Never mind. So tangent of 180 is still going to be y over x. So y is 0, x is -1, so tangent of 180 is still is also going to be 0. All right, let's take 90 degrees. First thing I want you to do for any quadrantal point, which is 0, 90, 180, 270, is write down the point and label the x and label the y. The reason we do this is because once you label the x and y, then finding sine, cosine, and tangent is easy. Sine is the y value, so sine of 90 is 1. Cosine is the x value, cosine of 90 is 0. Tangent is y over x. So if I take y, which is 1, over x, which is 0, then this is going to be undefined. Let's do 270. For 270, my point is going to be 0, -1. So always write the point and label the x and label the y. Now let's take the sine of 270 degrees, which is the y value, that's -1. The cosine of 270 is the x value, which is 0. And then the tangent of 270 is going to be y over x. So this is going to be -1 over 0, and that's again going to be undefined. So for all quadrantal points, whether it's 0, 90, 180, or 270, so that's going to be for 0 degrees, 180, 270, oh, I forgot 90, and then, it comes back to 360 as well. Use each point, 1, 0, 0, 1, -1, 0, 0, -1, and write down the x and y values.